Hello everyone. So your question said that the maximum possibility of hydrogen bonding in water molecule can form. Okay. So you have this is your water molecule. You have oxygen and there are two lone pair in your water molecule and there are two bond pair. Okay, like this. Okay. Now see, hydrogen bonding can be your from side your this side your hydrogen will form hydrogen bonding with other water molecule like this. Okay, this can form hydrogen bonding with other water molecule. Okay, like this. Or you can just direct the lone pair of this water. Okay, like this. Okay. This site lone pair can also form hydrogen bonding with your hydrogen. Okay. Lone pair can form your hydrogen bonding with hydrogen of water. Okay. Like this. You have water. This also form hydrogen bonding like this. Okay. So as you know, your this side is partially your positive and this side is partially negative. This partial negative, this partial positive. There's an interaction between partial positive sign and partial negative. They here also partial negative, here partial positive. So four sides are there by which your water can form hydrogen bonding. So correct answer is 4. This is how you have to approach this question. Hope you get your correct answer. Thank you. Bye bye.
हेलो फ्रेंड्स, आज का हमारा क्वेश्चन है द टाइप ऑफ हाइब्रिड ऑर्बिटल्स यूज्ड बाय द क्लोरीन एटम इन ClO2 माइनस। अब हम देखते हैं पहले ClO2 माइनस को। ClO2 माइनस, क्लोरीन के वैलेंस इलेक्ट्रॉन्स कितने होते हैं? 7। और तो ये और ऑक्सीजन की वैलेंसी कितनी होती है? 2। और O नेगेटिव की होती है वैलेंसी 1। ठीक है। अब अगर हम देखें तो क्लोरीन के 7 इलेक्ट्रॉन्स ये हो जाएंगे 7, 1 2 3 4 5 6 और एक ये 7। तो एक जो ऑक्सीजन है वो तो डबल बॉन्डेड रहेगी क्लोरीन के साथ, और एक जो है ऑक्सीजन नेगेटिव वो सिंगल बॉन्डेड रहेगी, और इसके ये दो लोन पेयर बच जाएंगे। ठीक है। तो अभी हम यहाँ देखें तो इसमें कितने आ गए? दो तो बॉन्ड पेयर आ गए। हमेशा डबल बॉन्ड एक बॉन्ड, एक तो ये डबल बॉन्ड, एक तो ये एक बॉन्ड पेयर और एक ये एक बॉन्ड पेयर। हमेशा डबल बॉन्ड एक ही बॉन्ड पेयर में काउंट होता है, तो दो बॉन्ड पेयर आ गए और दो ही लोन पेयर बच गए। तो टोटल स्टेरिक नंबर कितना आ गया? 4, या हम टोटल इलेक्ट्रॉन पेयर कहें तो वो आ गया 4। ठीक है। और 4 होता है तो इस 4 अगर आएगा तो sp3 होती है, और ज्योमेट्री क्या होती है? टेट्राहेड्रल। हाइब्रिडाइजेशन आ गई sp3। तो जो ClO2 माइनस है वो sp3 हाइब्रिड ऑर्बिटल यूज करता है ClO2 में, तो इसका ऑप्शन ए करेक्ट होगा। थैंक यू।
Hello everyone, let's start the question. The question says the molecule which has pyramidal shape is, right? So out of the following options we have to find out the molecule which has pyramidal shape. For that, firstly we need to find out the hybridization of the molecule, right? So firstly we'll find out the hybridization, and from the hybridization we will be able to predict the geometry of the molecule, right? And from the geometry we will then predict the shape of the given molecule, right? So firstly, to find out the hybridization, what we can simply do is, let's start with the very first option here, that is SO3. Now to find out the hybridization, you need to add the valence electrons present in the given atoms of the molecule. So we know sulfur has 6 valence electrons, so write down 6, plus oxygen also has 6 valence electrons, then multiply it with the number of atoms present. So 6 into 3 makes it how much? 18 plus 6, we will get 24. Now you need to divide this 24 with 8. Now after we know that it gets completely divisible with 3, right? It gets completely divisible with 3. So that means our hybridization will be what? We have to distribute this 3 in the form of sp-d orbitals. So we will get the hybridization sp2 for SO3 molecule, and we know that whenever the hybridization is sp2, then that means the molecule has which shape? The molecule has trigonal planar shape, So which means that this option is incorrect, because we have to find out the molecule which has pyramidal shape. So now we'll move on to option number 2. Now in option number 2, again we will calculate the hybridization. So I'll write H here. H is equal to valence electrons of nitrogen, which is 5, plus valence electrons of oxygen, which is 6, into 3, plus then add the charge. Since the charge is negative, it is an anion, so we will add the charge. If it would have been a cation, then we would have subtracted the charge present on the molecule. So here plus 1. Now what we will get here, hybridization 18 plus 5, and we will get here 24, right? So again we are getting 24. So that means the hybridization here will come out to be sp2 only. We are getting the same number of total valence electron, right? 24. And when we divide it by 8, again we are going to get sp2 this time. So that means this option is also incorrect. It does not have pyramidal shape. Now moving on to option number 4, we have CO3 2 negative carbonate ion. So let's calculate its hybridization, which is carbon has how many valence electron? Carbon has 4 valence electron, plus oxygen has how many? 6. 6 into 3, 18, right? Plus 2 negative charge, which makes it 24 again. Now again the hybridization is coming sp2 only. Now that means if it has sp2 hybridization, right, it has total how many valence total electrons are coming to be? Total 3 electron pair are coming. Now if it has 3 electron pair, then that means this is also incorrect, because the shape is what? The shape is trigonal planar, and we have to find out pyramidal shape. Now moving on to option number 4, we have PF3 here. Now for PF3, let's calculate its hybridization also. So it will be phosphorus has valence electron 5, plus fluorine has how many valence electrons? 7, into 3. So that means it is going to come out to be 26. Now we will divide 26 by 8. So it is 8 3s are 24 minus remaining 2. Again we are going to divide it with 2. What we will get here? 1. So when you add both the quotients here, that is 3 plus 1, we will get it equal to 4. Now what does 4 mean? 4 means that the hybridization is what? Hybridization is sp3. Now when the hybridization is sp3, I'll write it down above here. Whenever your hybridization is sp3, that means the geometry is what? Tetrahedral, right? So geometry is tetrahedral for sp3 hybridization. But if you clearly see that if the hybridization is tetrahedral, that means it should form 4 bonds. But here if you look at PF3, it has how many bond pairs here? The total electron pair is 4. I have calculated here. This is what your total electron pair. Total electron pair, then write down total electron pair. It is coming out to be 4. Bond pair is 3. Subtract. You will get 1. Now what is this one? The one is here lone pair. That means PF3 here has different shape than its geometry. That means the geometry is even though tetrahedral, but its shape is not equal to that of geometry, which means that because of this one lone pair, its shape will become what? Its shape will become actually pyramidal. So let me draw the shape of the molecule also here. So we have P, 3 fluorine atoms attached here like this, right? And because you can see I've just calculated here lone pair, that is one lone pair is coming out to be, so lone pair will be like this. So this is the shape of PF3, which is your pyramidal, right? Total electron pair is 4. 3 it is forming bond pair, and 1 lone pair. So it correctly fits the formula, and this is your correct answer. Option number 4 is your correct answer. Thank you.